On our first inclined plane, we are going to look at a situation where there's no friction and the mass of the object is 15 kilograms. So remember, with our free body diagrams, we have mg going that direction, and then of course our normal is perpendicular to the surface. Keep in mind we had talked about rotating our frame of reference really, so that our mg was really going this way. My normal force was going this way, and it would make it easier for us when we end up having some friction. Okay, so this mg we need to divide into its components. So this one is going to be mg sine theta, and this is going to be mg cosine theta. Remember when we were doing our vectors, it was x is for cosine, y is for sine, except on an inclined plane. That's because we have similar triangles right here. So that's a 20-degree angle with respect to the vertical, not the horizontal. So we have to be careful about that. Okay, so now that we have that, let's go ahead and figure out what the sum of my forces. It doesn't ask us the sum of the forces in the y direction, but we got to find our normal force. So in the y, we know this thing is not bouncing up and down as it goes downward, so it's going to be, I'm not sure why it's highlighting stuff there. We know that the sum of our forces is going to be equal to 0, which is going to be my normal force minus mg cosine theta. So let's go ahead and solve for normal force. If I bring that over, to the other side, my normal force is going to equal mg cosine theta. So all I did is I took this part right here and I put it on the other side. Okay, so that leaves me with a positive normal force, and then that changes my mg cosine to positive. So let's go ahead and figure out what this is. This is 15 kilograms times 10 meters per second squared times the cosine, and this is where on your papers I did not put a angle, but I told all of you to change it to 20 degrees. So we're going to say that our angle is 20 degrees. So let's go ahead and do that on our calculators. And so 15 times 10 is going to be 150. And then times the cosine of 20 is going to give us a normal force of 140.95 newtons. So just slightly less than the weight of the object. All right, so there's no force of friction to figure out, 140.95, because it is frictionless. So now we're going to work on our sum of the forces in the x direction, right? So the sum of our forces in the x direction is equal to just one force, mg sine theta. So mg sine theta, which is equal to 150 times the sine of 20 degrees. Now we also know the sum of our forces in the x direction is equal to mass times acceleration. So because both of those are equal to the sum of my forces, I can say 150 sine 20 degrees is equal to mass times acceleration. Well, this is the sum of my forces. Let's go ahead and figure out what that value is. So 150 times the sine of 20 should be a smaller number. So 51.30 newtons is equal to the mass, which is 15 kilograms, times the acceleration. Okay, so we know here's that sum of my forces I want. So that would be 51.3 newtons. And then to solve for my acceleration, I will divide both sides by 15 kilograms. Makes that go away, and my acceleration, now I just left it in my calculator, so it may be slightly different. 3.42 meters per second squared. So that is the acceleration of this object down the inclined plane. 3.42 meters per second squared.